Hi, this is John, VK3EDW, and in this video I'm going to show you how you can manufacture a printed circuit board using your 3D printer. In my case, the Ender 3. You'll need some PCB blank, a permanent marker pen and a scribe. So let's start with looking at the actual circuit that I'm going to produce.
Let's look at the PCB layout. This PCB is a single top layer with SMD components and Manhattan Island style component mounting with an overall ground plane. The board is the bandpass filter section of a direct conversion receiver. I'll just zoom in. This is where an SMD switch is located, and let's have a look at some sizes. Pad here is 0.5 millimeter wide, and the spacing between pads here is 0.2 millimeters. So the scribe needs to be very accurate. Here is a typical island, and here is the ground plane. So the ground plane is over the whole area, and the islands allow you to interconnect components and drop the other side to ground. These are the connections for switches to control lines for the switches, which come from another board. The board itself is going to be about 145, 150 wide and about 212 millimeters in length. So it's a fairly large board. I've generated the Gerber files using the output manufacturing plots. I use Design Spark PCB to do all my PCB layouts.
The cleaning of the PCB is quite straightforward. First of all, get some very fine grade wet and dry, just to shine up the copper. Not too heavy pressure because the copper is quite a thin layer. The next thing to do is to have a clean up of with acetone, and acetone will clean that up quite effectively, and you will have a clean, ready to use PCB blank. And there's all the muck that's come off. From this point onwards, you've got to make sure that the copper side doesn't get touched by your fingers. Now, I've placed it face down onto clean paper towel. I like to use double-sided tape. I use these double-sided large pads that I get from the $2 shop, 4 for $2. So I'm just going to I've placed one on. I shall just peel off and place the next one. Good pressure, bit of an overlap, and that will be cut off. Now hold the board by the edges from now on, and there's a strip that's just got to be cut off, and there's your board. This project that I've got requires a large piece of copper because it's going to be a large print, and the size of the copper is totally dependent on the board that you're using. The principle is the same. Wash. Right, now we're going to look at the actual attachment that goes on to the Ender 3 print bed. It's made of 3 pieces of wood, 2 pieces 235mm square, with a smaller one sandwiched in between. That allows bulldog clips to attach the base of it to the bed of the 3D printer, and this is the surface that the PCB will peel off the double-sided tape backing. Get a piece of paper towel handy. You're going to align the left hand side with the left hand side of the board. Just use your fingers, and we're going to put this and use the paper towel to press down this way. You don't get any fingerprints. The board's usually a little bowed, and this gives a really good adhesion of the glue. Here's the scribe tool that I've made. This is the printed assembly that fits snugly over the actual plate of the hot end mounting plate. One screw M3 bolt attaches and clamps it. Here's the actual scribe, which is spring loaded, a plate over the top. You have to make the hole for the actual scribe quite precise because you don't want any slopping around. The actual scribes, I've used a broken one of these. These are metric. This range is 0.1 to 0.6, I think, millimeter end mill bits. $4 from eBay, China of course. But the actual shaft is 1/8 of an inch. The tip is tungsten carbide. And what I've done here is I've taken the broken one and I've ground it to a very fine point, slightly rounded point. It's probably about a little less than 0.1 millimeter, but there it is. The springs, I bought a pack of these years ago, thinking they would be useful one day, and sure enough they become useful. I suspect you could use the spring out of a ballpoint pen, but you just need something that is giving you quite a reasonable amount of resistance, but not too hard to lift. And that's the mounting. One modification to the printer is a little extension cable for the Z-axis 0 switch. This needs to be brought up so that you can actually get reference to the higher bed level. And when you take all your print head off, put it to one side in a bag along with its 4 screws, and then it keeps it out of place. But you'll need to use a cable that's longer here, so just make up a little extension cable. Okay, we're going to put the scribe mount on the printer. I'll just raise the head up, make it easier access. Disable the steppers. As I said, the head fits snugly on, and I line up the hole and the single bolt. That's quite solid, and the scribe pops up and down, and there's the mount fitted. Quite simple. Do another auto home. Now the scribe itself wants to be lifted about 3.5 millimeters, and that will give reasonable pressure. And so I'm going to lift the Z-axis by 3.5 millimeters, and that will give us a good the right level to level the plane to. I'll set it to 3.6 millimeters. Now you need to disable the motors, and now we're going to level the plane to the scribe at 3.6 millimeters, and when we scribe, we're going to be scribing at 0, and so there will be a lift on the scribe of 3.6 millimeters. The scribe is now at 3.6 millimeters raised, and we're going to flatten the plane. This is quite easy. Use your multimeter in conductivity mode. Connect one probe to the circuit board, one probe to the scribe. Move to your first leveling point, and lift the bed. And there's the point. And just back it off, slide across, adjust this a corner, back it off slightly. Now there's that corner, and there's that corner. So now the bed is level at 3.6 millimeters lifted on the scribe. When we scribe at 0, there'll be actually that lift on the scribe giving good pressure across the board. And that's your plane leveled and ready for scribing. The next step is to determine the offset between the printed circuit board and the scribe. So we do an auto home. And what we're looking for is the distance from the scribe to the start of the printed circuit board. In this instance it's about 15 millimeters, and if you were doing a small board that was just mounted on the platform, you need both X and Y offset. But in this case I've got plenty of extension, it's overlapping. I've added a little bit of tape from the front leading edge and the underside because the overlap was lifting a little, and the PCB will be starting around about here anyway. So I've got a 15 millimeter offset in that direction. Right, now it's time to apply the permanent marker. I like to lift the head up. Quite a lot. Disable the motors, steppers, and now you can start applying the texture. There. Now that's pretty well coated, and we leave that to dry.
The software program we're going to use to generate the Gerber file for the 3D printer is a program called Flatcam, flatcam.org. It's a software program that's used to generate G-code for PCB milling on a CNC machine, but the same code can be used on your 3D printer for using a scribe. So we'll open up Flatcam, and here we are in Flatcam, and the first thing to do, I set the options for millimeters, and we'll go to project, and we'll open a Gerber file. And you go to where your Gerber file is, and there's my Gerber file, quite a large one. It takes a while to load, and here it is. And you can see, as before, there's the SMD pads, and here are the islands for the bandpass filter. Now, we measured before on the 3D printer the offset from the scribe to the PCB. So the first thing we've got to do is provide an offset here, because everything is referred to 0, 0. And we had an offset of 15. I'm going to increase that a bit to 25. I'm also going to provide a Y offset of 25. So you just simply change this to 25X, 25Y, and there you go, it's now offset. The next operation is make sure you've got Gerber selected, we're going to generate the isolation routing. The tool diameter I'm going to leave at 0.1. I'm going to have 3 passes. So there'll be 3 passes over the scribe. And the overlap of the passes, I'm going to make 0.5 of the width of the tool diameter. I'm going to combine all passes and generate geometry. And here we go. Now I'll zoom in and we can see here are the 3 passes. And if I go to the fine detail here, this distance was 0.2 of a millimeter, and we've got the 3 passes cutting between, so that will be taken out. There's no cutting into the pad, it's around. This is copper, and this will be the ground plane. This is one of the islands. This is another island for the Manhattan type. Now we go and select the isolation file, and we're going to create a CNC job. Now the cut, Z, that's the depth. That's going to be 0. That's the 0 on the Z-axis. When it's traveling above the board, I'm going to make that 8 millimeters. The feed rate, I'll do 200. 183 millimeters a second, so tool diameter 0.1, spindle speed we don't need, and we'll generate. Takes a while. Only because it's a large. Now we can see the actual route. These are the actual cuts. So this is the actual cut. We can look here, make sure there's a definite cut through the finest area. Now the next step is to provide a cutout. We're not actually going to be cutting out, but I'd like to have an outline so that I know where the edges of the finished board are going to be, and I can then cut the printed circuit board to that. Go to the original file, the Gerber, go to selected and go to the board cutout. The tool diameter is 0.1, that's our scribe. The margin is the margin between the extremities of the PCB layout and where you want the cutout to be, or the board width. I'm going to have an 8mm gap around the board. I'm going to put gaps top and bottom. They would normally be used in a milling process to leave little tabs where you can pop out the printed circuit board. Anyway, I'll do a board cutout, generate the geometry. And there it is. I'll go to the cutout, Gerber cutout, and generate a CNC job. We're going to have milling at 0 depth, travel is 8mm, I'll leave that at 180, tool diameter 0.1, generate. We've now got a CNC for the PCB and a CNC for the cutout. Now we'll select the CNC for the PCB, and we're going to generate the G code. There's nothing to do in here. Tool diameter, update plot pans. We're just going to generate and export G code. Give it a file name. Band pass filter, PCB. G code. And we do the same for the cutout. And PCB cutout G code. And there's the job done. We've generated the tool path for board outline, the actual PCB layout, and we've also now generated the G code. There is one further stage with the G code files. Open them up, and the speed needs a G0 in front of it for Marlin to recognize it properly. So you just put a G0 in front of the F100, F180, and save it. And do exactly the same with the other folder. File G0 and save. And now the files are ready to transfer to your memory stick for processing on the printer.
The memory card has been put into the Ender 3, and we will do an auto home. And that gives us our first reference point, and we're going to print from the SD card, and to start with we're going to do the cutout, which will give us the extremities of the board, which will give us the lines to actually cut the PCB when it's finished, and we'll do that first. This process can be speeded up by changing the F180 to a higher number, but you need to get a good clear scribe line. Now we're going to do the main part of the circuit. First step is to auto home. Just make sure it is actually set to the right position for 0. Then we've got the same reference as the cutout. Now we go back to print from SD, and we'll go to the band pass filter PCB code. And here's the finished board. Now we're going to do the etching. I use ammonium persulfate for etching, about 70 degrees. Usually takes 5 to 10 minutes. And here's the completed board. Now that the ink has been cleaned with acetone, and hopefully you can see the etching. Here's the completed PCB. Well, I hope you found that video useful. The whole process of scribing the circuit, being a large board, took an hour. But if you were only doing a small board, it would take a lot less time. But certainly for one-offs, it's a good process. And the Manhattan style of building a circuit is extremely useful, particularly in RF. 73. Vote if you like the video, and do ask questions.